So now let's dive a little bit more into acids and bases. So we talked about acids a little bit when we talked about ionic compounds. When we talked about electrolytes, When we said that acids are molecular compounds that ionize when they dissolve in water. But how do I look at a substance and know if it's an acid or not? How do I look at a formula and know if it's a base or not? So we're going to talk about some definitions of acids and bases. Now we're going to have two different types of definitions. We're going to have the Arrhenius definition, and we're also going to have what's called the Bronsted or Bronsted-Lowry definition. One definition, the Arrhenius definition, is going to be based on the formula. So you can just look at the formula by itself and just see, okay, what is it composed of? What is in the formula? The Bronsted definition is going to look at how is that molecule behaving. So based on its behavior, I'll be able to determine if it's an acid or a base. So one is based on what it's made out of, its composition, and one's based on its behavior. So let's look at the Arrhenius definition. The Arrhenius definition says that an acid is a substance that contains hydrogen and produces H plus or H3O plus, which is hydronium. When it produces these ions in aqueous solution. Now we'll talk a lot more about acids. There's a whole chapter next semester about acids. The reason we have H plus or H3O plus is because the acid could produce H plus in water, because it's aqueous, and react with the water to make H3O plus. So sometimes you need a CH plus and sometimes you need a CH3O plus. Just depends on how you're looking at it. So these are going to have H and produce either the hydrogen or the hydronium ion. A base is a substance that contains a hydroxyl group and produces hydroxide ions, which is OH minus, in aqueous solution. So they have an OH in its compound in the formula, and it's going to produce OH minus when I separate it. So an example of an acid would be HCl. I see that there's an H present in the formula, and when I separate it to its ions, it produces the H plus ion. An example of a base is NaOH. I can see the hydroxyl group in the formula, and when I separate it, I produce OH minus ions. So that's my Arrhenius definition. It's based on just looking at the formula and what it contains. The opposite, which is the Bronsted, or in the book you might see Bronsted-Lowry definition. This is going to talk about how the acid or base behaves. So an acid is a proton. Now, I don't want you to think about protons, neutrons, and electrons here. The reason we're using H plus and calling that a proton is because H plus actually has only one proton. So it behaves like a proton. But we're talking about the H plus ion, the cation. Okay? So when somebody says proton, they could be talking about that subatomic particle or talking about H plus. It depends on if they're talking about acids and bases or not. So an acid is going to be an H plus donor. It's going to donate, get rid of, lose an H plus. A base is going to be an H plus acceptor. It's going to gain an H plus. So what we're going to look at is we're going to look at a little bit acid-base reactions. These acid-base reactions are a transfer of H plus. So the acid is going to donate the H plus and give it to the base. So acid loses the H plus and donates it to the base. The base accepts the H plus from the acid. Okay? So that's going to be an acid-base reaction when an acid and a base react together. This is what's going to happen. Now, another side definition we need to talk about is water. Water is what we call amphoteric. So what this word means is that water can act as an acid or a base. It's going to be able to pick how it behaves based on who it's attached to. So if water is with an acid, then water will be a base. If water is with a base, then water will act as an acid. So water is going to behave based on who he's with. So if he's with one guy, he'll be acting out like the other one so that they can kind of balance each other out. All right, so now let's get a little bit deeper into our acids and our bases. How can we really know what's an acid, what's a base? Let's talk about some properties. So we said acids are molecular compounds that form H+ when dissolved in water. That's how we defined an acid in a more specific way. Usually when we're talking about an acid, it's going to have the AQ state after the formula. So usually you'll see it written with the AQ in parentheses, like in the reaction. Because this has to be a molecular compound dissolved in water. If it doesn't have the AQ and it's a liquid or a solid, then it's not an acid because it has to be dissolved in water. Some properties. Acids are what give us a sour taste. So sometimes if you eat like sour candies, you might see that they have a certain acid in the ingredients list. And that acid is what gives it this sour taste. Some acids are so strong, so acidic, that you can't just eat them. Okay? These acids are so strong that they can actually dissolve many metals. Okay? So some of our acids, we can eat them, and some of them are really strong. They're actually going to dissolve many of the metals. And when we're looking at the formula, my formula generally starts with an H. So example, I've already written HCl several times. H2SO4, HF, starts with an H. Okay, so this is kind of some general characteristics of my acids. So I kind of have this picture here just so you can kind of see what I'm talking about. So when I say that these can react, I can have some HCl. So here's my HCl here, and then my zinc is added. And what happens is my HCl is going to react with this zinc, and it's actually going to dissolve it, and it's going to do a reaction with it, so the HCl reacts with the zinc, and it will bubble because it's producing H2 gas. And the H2 gas is going to come off. And if you let this sit here long enough, all the zinc is going to go away because it's taking the solid zinc and now it's dissolving it as an ion in solution. So it doesn't just disappear, it just changes it from being a solid to aqueous, and so now the ions are floating around and we just can't see them. Okay? So now they're here in solution, floating around with my other ions, and so it looks like there's nothing left, but it just changed from being a solid to a ion. All right, so now let's talk about some common acids and bases. So I'm going to give you charts, and we're going to talk about those, and we're going to start talking about how do we name and write formulas of acids.